Guys, I am running NVIDIA's Frame Warp Reflex 2 technology, and it looks weird at the edges of the screen, doesn't it? But how am I running this? This isn't actually released, so what is going on here? And also, what is Reflex 2 and Frame Warp? So when NVIDIA launched the RTX 50 series GPUs, they advertised some of the new features like multi-frame gen, but also Reflex 2 with Frame Warp, which promised to dramatically reduce latency. And they gave demonstrations of like 60 milliseconds down to like 15 milliseconds of latency. How is this possible? And we still haven't seen it in actual games. Well, the idea of how this is possible and the sort of issues it could produce, which might be why we haven't actually seen it yet, result because in-painting is required. Again, I think requires a little bit of an explanation on what actually is Reflex 2 and why is this so different than Reflex, and like I said, why are we maybe seeing some problems that might explain why we haven't actually seen this completely officially yet. But also we get to kind of try this out. And how did that happen? So a modder reverse engineered some files from games. That's what happened. More on that in a minute, but what the heck is Reflex 2? So here's the idea. So latency, when you experience it in a PC game, is basically when I move my mouse, then I will see the screen position change on my monitor. But there's a time gap in between moving the mouse and seeing the effect of that movement on the screen. And that is latency, that amount of time. So normally the way this works is you move the mouse, and then the CPU reads the mouse position, which is then submitted to the render queue for the game. The GPU renders what the frame looks like, and then that goes to your display. And this could take, in this particular example they're showing here, maybe that's 14 milliseconds of latency, etc. But here's the point. What Reflex 2 does is it says, okay, you move your mouse, it goes to the GPU starts rendering the frame, and then it reads the mouse position again for where your mouse is now, not when it started rendering the frame, but right before the frame goes to the display. So then what does it do? It warps the frame. It literally like bends the image to better fit where your mouse is now, not where it was when it started rendering the frame. But there's an obvious problem with that. If it warps the frame for your new mouse position, then there will be things missing that when objects are changing in their position based on your latest mouse movement. So like there could be, like if your mouse has moved over this character's head, then the whole screen shifts, which means you would be able to see stuff behind this character, or from the edge of the screen, now that the mouse has turned, you would be able to see stuff that was previously off screen here. So that would just be literal holes in the image. So the idea then is to fill in those gaps with what they're calling in-painting, and what I feel like is a very misleading image. This is from NVIDIA when they announced the technology, which made people, I think, feel like this in-painting might be able to do more than it really actually does. Because I can understand blending this wall color behind here and having that look reasonably okay, especially if you're switching frames super quickly in an esports title. But they're making it look like the game would suddenly be able to tell that there was like stuff here that wasn't here previously, and that it would just in-paint that there. And that is not how this would work at all, by my understanding. And so the idea is that it does make your mouse position more immediately responsive to what you're seeing on the screen, but at the cost of the image because of that weird in-painting stuff. So again, if we watch this again, with in-painting off, all this extra stuff is revealed behind the image. With in-painting on, it's filling in those gaps, probably just by blending in the colors nearby to make it look a little bit more seamless. And then we get to try out something like this and see what that looks like. Now notice I'm running at 30 frames per second right now. So at a low base frame rate, there's gonna be a huge difference between what's happening at the edges of your screen and in other words, like if you move quickly, your frames are only updating so far. So if there's a lot of new stuff revealed in between those frames, the in-painting has a big job to do, and it might not look great. But also, since this isn't released by NVIDIA, what is this? How am I trying it out? And should we expect this to be the actual technology that we end up getting? So, basically, every morning I wake up and scroll the latest tech news, and I saw this article at videocards.com. I'll link my sources in the video description today. So Pure Dark releases free demo of NVIDIA Reflex 2 Frame Warp, works on RTX 20 GPUs. Okay, so what is this all about? So Pure Dark is a well-known modder in the PC space, and he has a Patreon set up where sometimes you can get, I think he was one of the ones that was like modding frame gen into games before that was a supported thing in them, things like that. Now, even though this is posted to his Patreon, it is a free demo and we can download that. But how did he get access to this? So if we go ahead and follow up the link to Pure Dark's Patreon, we get a little bit more information here. I'll open in a new tab, so I'll still have the article there if we need it. So he has a demo video of himself trying this out. The language he's speaking in the video is Chinese. But he did put a text post explaining a little bit of what's going on. So he mentioned that he reverse engineered the nvngx_ratewarp.dll, which was leaked in the public testing of Arc Raiders. So Arc Raiders recently had a server slam public test. Apparently it had this file in it. Rate warp seemed to sound like frame warp stuff, so he was able to reverse engineer that. Now, it says that later it was discovered that this file was already included back in the finals back in May. Now, interesting to note, the finals is one of the games that has been NVIDIA had been using since 10 months ago when they announced this technology. And seriously, where is it, NVIDIA? As a game that was going to be one of the launch features for it. But again, it still doesn't actually exist in the game. Now, he says that if he had discovered that was released in the finals in May, he could have been made this demo back in May. Now, he also says that according to NVIDIA, Reflex 2 is only supported on 50 series at launch, but he's saying that it should even run on 20 series cards. Now, I'm going to go ahead and test it out on a 5090 right now just to give it the best shot at running. But again, I think it is important to note that this is a reverse engineered file from a modder in a leaked DLL file, that came out as part of a game. But this is not something that has been officially implemented yet, which means that I do think that while we can judge what we're seeing in this demo, I think we should also hold off and say that, if this hasn't been officially released yet, maybe that's because they're continuing to improve the quality. So this is a fun sneak peek at what's going on and a chance to get to try it out. But again, I think this is not the same thing as reviewing what this is like in an actual fully released game whenever NVIDIA deems that it's ready for public viewing. Now, there's a Google Drive link here where you can download the file. Keep in mind that Google says that they can't, scan it for viruses, etc. And when you run this file on your PC, it is going to warn that you are trusting that this file is safe. And not, virus ridden or anything. I can say that I have ran the file and I'm not experiencing anything I think is a virus. And Pure Dark does have, he is a well-known modder with a Patreon where he makes money. If he was releasing malware to people, he could lose his revenue stream on Patreon, lose his reputation, etc. So I'm not saying you shouldn't trust this. But I'm just mentioning that when you download things like this, you are always doing so at your own risk. Also, I'm running this at 1080p because this text was incredibly small. when I was trying to run this at 4K. So I did try this out at 4K, and I was like, that's not going to work super well. And I have not tried this out much because I just wanted to kind of film the video as we get some reactions for it. Also, I'm getting some additional metrics up here that include PC latency, and I'm not sure it's correct. The software I'm trying to measure the PC latency with is NVIDIA's FrameView technology. It's one of the few stat analyzing software programs that does report a latency metric. But I'm not sure it's working properly with FrameWarp because the numbers seem too small. Anyway, let me turn FrameWarp off for a second, though. Also, let's talk about how I'm capturing this because it has its limitations. I'm capturing with an HDMI output to a second PC that I'm actually doing the recording on, and that PC is capturing a 60 FPS YouTube video. It's not variable refresh rate. And so I think maybe, at least for now, we'll try kicking on VSync to reduce screen tearing. Because if you're not using, notice FrameWarp's off right now. If I have VSync off, you might be seeing some screen tearing. That is not FrameWarp. That's the out of sync capture happening when we're not in a variable refresh rate capturing situation, if that makes sense. So with VSync on, notice that we don't see that screen tearing, and FrameWarp is off. Now, I can definitely feel some latency in between my mouse movements and what I'm seeing on screen because we're capped to 30 FPS, so it doesn't feel immediately responsive. And FrameView is reporting that PC latency is like almost 60 milliseconds. So there's almost 60 milliseconds in between me moving my mouse and when the image is being sent to the display. That makes sense? That's the PC latency. Now, what we're gonna do next is turn FrameWarp on. So turning FrameWarp on, I can say that it does feel a lot more immediate where my mouse position is with what I'm seeing on screen. Also, the edges of the screen look insane right now due to that in-painting, okay? That's not screen tearing. We are VSync locked right now. That is weird in-painting issues. Now, PC latency reported on FrameView is now in the 30-something millisecond range. That may be correct. I don't know. Again, I'm using software to monitor that, but I can also give my subjective experience. It does feel more immediately responsive. Although one thing I don't like right now is that this is kind of a click to drag style situation. So I'm like clicking to drag the mouse view rather than this being like feeling like a first person shooter where when I move my mouse around, it moves. So in other words, I don't think this is amazing. Now I can use WASD to move. And notice when I move forward and backward, you're getting some weird stuff going on anytime something is being revealed that shouldn't be revealed. Do you see what we're saying? So this is where that in-painting is showing its weaknesses. But again, we're at 30 frames per second. So there is a large gap in between, what's happening, on screen and, the frame when it started being rendered. So I think this is going to improve greatly when we increase the frame rate. But for now, we want to try it out at different frame rates. Also, if I pan left and right, look at this like robot dude. Is he a robot? What is this? Like, honestly, what am I even looking at right now? I don't know what this thing is. But yeah, as I move back and forth, forward and backward, you get one type of artifacting. But yeah, left and right, oh boy. Again, let's turn FrameWarp off again. So here's moving left and right, no FrameWarp on. Here's moving left and right with FrameWarp on. Kinda some crazy stuff. Okay, but here's the idea. I think that this technology is obviously targeting esports games, which are generally running at a high frame rate. So let's start increasing the frame rate and seeing what happens. So 60 frames per second is now our cap. And we are now going to try moving left and right. And yeah, things still look kind of crazy. Let's again go FrameWarp off. Okay, so FrameWarp off. Things look all put together. We're getting a nice 60 FPS. Everything looks smooth. Again, when I move my mouse, 60 FPS certainly doesn't feel awful or anything like that. But then if I turn FrameWarp on, let's go ahead and see how things go. Okay, yeah, the FrameWarp certainly looks kind of weird here, guys, right? We're still having some issues. Now, again, I can also try this with VSync off, which is going to introduce more screen tearing to the picture. But now my PC latency is reporting like less than 1 millisecond of latency. I don't think that seems right either, but things do feel more responsive if we're not waiting for VSync. Now, I think that's probably because of the probably the way the actual Reflex works, which has to do with like syncing frames, and VSync can add input latency. So again, this is hard to capture. So I really think that you guys, again, if you trust the download file and stuff like that, you'll probably have the best time playing around with this in person. So I'm trying to describe and capture what I'm seeing. But it's not a perfect situation. Again, if I remove the VSync, I think things are actually looking less distorted. So I think removing VSync looks better, but it's not that there aren't still some kinds of issues. Let's go back down to 30 FPS again without VSync. And yeah, 30 FPS, it's still pretty crazy here, especially on this like horizontal tracking here. Again, I think VSync makes it even worse and a little bit more latency. So I think for the purposes of this, I might leave VSync off. Just realize that if you're seeing screen tearing in the traditional sense, that's because we don't have VSync on and we're not on a variable refresh rate situation. So it's like I said, it's just one of the issues with capturing this right now. Now let's try going up to 120 FPS. So 120 FPS, this is frame warp on. And my capture card does go to 120, although the YouTube video you're watching is going to be 60 FPS. So again, there's a difference between what I'm going to be seeing in person and what you're going to be seeing in person if you are actually doing this. Okay, at 120, this is not terrible, okay? Panning the screen, the edges of the frames and things, this is not bad. Okay. So yeah, this is where I really think this technology makes sense when running at extremely high frame rates. Because even at 60 FPS, I don't think it was good enough. At 120, yes, I can see some issues. Let's go ahead and turn this off. And again, you're watching a 60 FPS YouTube video, so it's not going to be perfect for you. So like this is with frame warp off, and when he moves all crazy and stuff, like I'm not seeing any weirdness and pixelation around the edges. But when I turn frame warp on, I do see some weird pixelation, like kind of when he moves quickly, and especially when I strafe horizontally. Do you see weird pixelation around the edges and things like that? See, that's going to be a problem. So even at 120, it's certainly not perfect. But if you're playing an esports game, maybe at like 240, let's see what happens with that. So at 240, again, there might be some weirdness. Yeah, I can still see some pixelation and weirdness as I do this horizontal strafing. Again, you're watching a 60 FPS video, not 240. My monitor does go to 240, but the capture here is not going to be 240. But yeah, I think that's, and yeah, and the inpainting at the edges of the screen is not too crazy now or anything. So this is really interesting to play around with. Now again, past this point, like my monitor does go into 480 hertz 1080p mode, so like, you know, I could go to 480, but you're not going to see anything like what's there in person or anything like that. Now the point is that basically, I think what we can establish is that at least in its current format, the format that is a reverse engineered version from some game files that NVIDIA didn't seem to want public quite yet, at least in that version, I will say that this only seems to be somewhat worth using at very high frame rates. At 120 is where it stopped being utterly hideous. 240 seemed fairly acceptable. I think if you are like 480 hertz plus, I think it might make sense. And remember that the use case here, I think, is in competitive online games, where oftentimes it's not about what the game looks like. I think usually people are turning down to the lowest possible graphic settings to get the biggest competitive edge by reducing clutter and increasing frame rate and responsiveness. So I do think this is an interesting technology, and I do think it has its place in competitive games, potentially. But I would say that I think outside of that use case, at least if the image quality is anything like what we're seeing here, I think that it's going to be really more, like I said, in that niche use case of the, not that like competitive gaming is like some super small niche. I just mean like it's a subset of all games ever, right? Like, you know what I mean? So I think the higher the frame rate goes, the better. And it can make 30 FPS feel more responsive. But the image quality issues that we're seeing go along with that is pretty considerable, okay? So anyway, this is, like I said, it's hard to adequately communicate responsiveness stuff in a video capture. And even the video artifacts aren't going to look the same to you in the video capture as they do in person on a screen, especially on a variable refresh rate screen. So, like I said, you could try this out for yourself. I will link all the sources in the video description. But I thought this was a fun first look at the technology and thought I'd bring this to all of your attention. I hope all of you have an excellent day.